to factor that. Okay, it's like a slip and slide problem. Why don't we rewrite it so it looks more like a normal one? We're used to seeing our square term first. So that was the negative 3x squared, then our minus 4x, and then our minus 1. Now I told you for slip and slide, we really want this first term to be positive. So what should I do before I slip and slide here? We'll just factor out that negative. Okay, now we can do our slip and slide with this inside. So the negative I took out just stays. What multiplies to 3 and adds to 4?
3 more.
And then we divide our 3 back. So 3 divided by 3 is 1. And 3x plus 1. So if things are written in a different order, feel free to switch them around. Also make sure your square term is positive before you slip and slide. I want you guys to try a problem. Let's do this one. So we start with what? Gotta have our GCS, so we take out that 3x. So now we just need to know what multiplies to a positive 16, adds to negative 8. That's negative 4 and negative 4. Or you could write that as x minus 4 squared. I'll accept either one. Doesn't matter to me. All right, good. So you guys all remembered how to take out the GCF. Let's look at, I'm going to jump around a little bit. If we're doing okay, I'm skipping a few of our problems. How many terms are in this? 2. This is a term, and this is a term. Okay, they're pretty similar. What's the only difference between them? Excellent. Okay. So we are going to take out the GCF, which is x squared plus 4. When we're taking out a GCF, we have to look for the smaller exponent. So what exponent is smaller? 3 halves or 7 halves? So if you take that out, if you take out the whole thing, what do we put? What's anything divided by itself? 1. All right, when I took it out of this one, that's like subtracting your exponents. What's 7 halves minus 3 halves?
2.
What if I told you to clean that up? What would you have to do on this inside? If you want to square x squared plus 4, that means you have 2 of them. We have to FOIL that. So we get x to the 4 is 4x squared plus 16. Combine like terms. This is like a quadratic. Is there anything that multiplies to 17 and adds to 8? No, so that's our final answer. So we did have at the beginning some uglier GCF problems. This is one of those. I'm just showing us how to deal with that. Same strategy, you take out what you can. All right, I'm going to put a couple up here for you. Alright, the first one. Not very many of you guys got this one. We have two terms. What can you do first? So we take that 2 out because we have a GCF, and you always check for that GCF first. But x cubed plus 8, what should that remind us of? Sum of cubes that we wrote down yesterday. So you have that formula in your notes. So the 2 just stays. A plus b, so this would be x plus, what to the third power is 8? 2. Alright, first one squared, so x squared minus first times last is 2x, plus the last one squared, 2 squared is 4. And that would be our answer. On B, this one is like a quadratic. My exponents are just different. But it's like a quadratic because we have 8, half of 8 is 4, and then we have a constant. So when we set it up, b to the 8th, so each one gets 4. It'll always match this middle exponent. What two numbers multiply to 14 and add to 9? Alright. Let's do one more. If I look at this one, we have 4 terms, no greatest common factor. So what do we have to do? Right, remember there can't be a subtraction. If this were minus 2x, I have to make it plus negative first. What can I take out of the first set? That would leave us with x minus 4. Second one we can take out 2, and that leaves x minus 4. Now we have 2 terms. They both have x minus 4, so we take that out. When we do so, we are left with x squared plus 2. Always verify that you can't factor that any further, that it doesn't have a GCF or a difference of squares or anything.